So, uh, have you ever spent hours or, maybe even days just trying to anticipate every single way something could go wrong?
Oh, absolutely. Like you just sit there mapping out all the contingency plans.
Right. Setting up guardrails, writing out warnings for your team, or even just for yourself, really.
Just building this massive defensive wall.
Yeah, exactly.
Yeah.
Only to have this sudden, like, facepalm realization that you could have just designed the system so making the mistake was physically impossible in the first place.
It is a profound realization when it finally hits you. I mean, we tend to spend an enormous amount of our energy defending against disaster
Yeah.
rather than simply, removing the possibility of that disaster existing at all. We treat problems as inevitable forces we have to fight instead of design flaws we can just engineer out of existence.
And that shift in perspective, that is the entire mission of today's deep dive. We are looking at a really brilliant mental model called making illegal states unrepresentable.
It's such a great phrase.
It really is.
Yeah.
And our source material for this comes from a developer named Ang. It's a blog post, specifically an entry titled Notes on Haskell-Programming, Part 207. Stop defending against impossible states.
And look, before you panic.
Right, yeah, before you think this is going to be some dry software engineering lecture. Yes, the source is fundamentally about the Haskell programming language, but
you do not need to know a single line of Haskell to get massive value out of this, I promise.
exactly.
The code is just the vehicle, really, to explain a much larger philosophy about system design.
Yeah, because whether you are like a programmer writing code or a manager building a team workflow or, just someone trying to organize your daily routine,
Right.
this concept can completely change how you approach problem solving. It basically all comes down to structural integrity.
Totally. And to set the stage here, we need to understand what Ang was actually trying to build when this realization occurred.
Okay, yeah, let's get into that.
So Ang was working on a Ket project that involved parsing the structure of a book.
Okay, parsing a book.
Right. Think about how a typical book is organized. You have large volumes.
Sure.
Within those, you have chapters. And then you have like smaller elements like keywords or subheadings.
Makes sense.
So Ang was writing a program to read that structure, parse it, and just make sense of it for the computer. But during this process, Ang realized the code they were writing was just bending over backward to accommodate things that shouldn't even exist in reality.
Okay, let's unpack this. Because to understand how to fix a system, we first have to understand why it was broken.
Right.
So let's look at Ang's original overarching setup. They started the way I think, honestly, a lot of us would start.
Yeah, by creating one giant generic bucket for every single part of the book.
Exactly. In the code, it was called a generic block.
Right. So in that original code, Ang defined a block using a structure called a block header.
Yeah.
And this generic block header was designed to hold everything. It took a few parameters to define what it was actually looking at.
Like what kind of parameters?
So a header type to say if it was a volume or a chapter. An integer representing what level it was at.
Okay, got it.
Some text for the title, and finally something called header info, which carried extra metadata like chapter numbering.
Now, on the surface, that sounds incredibly efficient.
It does.
You have one tool that can describe anything in the book. It's flexible. But here in the analogy I want to use for this, to kind of show why it falls apart.
I love a good analogy.
Imagine you are tasked with designing a brand new form for the government, a vehicle registration form.
Oh, boy. Okay.
Because you want to be super efficient, you make one single, highly generic form for every single vehicle on Earth. Cars, boats, bicycles, airplanes, submarines, all on one form.
Right, a truly generic bucket trying to capture the entirety of transportation.
Exactly. So now imagine a bicycle owner is filling out this form. They input their name, their address, the fact that their vehicle has 2 wheels. And then they get to a mandatory section that says number of jet engines.
Right, which makes no sense for a bicycle.
0 cents. It's technically a very flexible form, but it allows for ridiculous, impossible combinations. Like a bicycle with a jet engine is an illegal state in reality.
Because it doesn't exist.
Right, it doesn't exist, but your bureaucratic system allows it to be documented as if it could.
And that maps directly onto what happened in Ang's code. Because the block header was completely generic, it allowed what programmers call these illegal states.
Right.
The code would happily accept a block header defining a volume at level 2.
Which makes 0 sense if you think about a book. A volume is the top-level container
Exactly.
and is implicitly level 1. There's like no such thing as a sub-volume operating at level 2 in this context.
Or even weirder, the code allowed a block header for a keyword, set to level 1 with a title, but also with that header info attached to it.
And remind me, the header info, that carries data about chapter numbering, right?
Yes. And keywords don't have chapter numbers.
Right. They're just keywords.
What's fascinating here is the hidden cost of this generic design. It's not just that it looks a little messy on paper. When a system allows for nonsense, the person managing that system, or in this case, the computer program running it, it has to constantly check to see if the data it's looking at is nonsense. It forces the system into this state of perpetual paranoia.
So the system constantly has to interrogate its own data. It's like the government clerk processing that vehicle form and having to stop and ask, wait, does this bicycle actually have a jet engine? Let me call the owner and verify.
Yes, exactly.
Oh, it doesn't? Okay, I'll cross that out.
Right. Every single time the program encounters a keyword, it has to stop and say, wait, does this keyword have chapter numbering attached to it by mistake? Let me write some extra code to check for that, and then tell the system to ignore the numbering if it happens to find it.
Wow.
It introduces massive cognitive and computational overhead. You are actively creating new problems just so you can write solutions for them.
Which brings us to the specific mechanism that was causing Ang so much of this headache. It's a well-intentioned programming tool that completely backfired. It's known as the maybe trap.
Ah, yes. The maybe type. It's a core concept in programming.
Okay, explain that for us.
In Haskell and a lot of other languages under different names, a maybe type is a way of explicitly saying a piece of data is optional.
Right.
It means the data might be there, or it might be literally nothing.
So, looking at Ang's old code, they heavily use these maybe types for the optional fields inside that header info bucket we just talked about.
Yes, they did.
Specifically, fields like the prefix, the number, and the unit. For example, the code for the header number was written as high number is maybe text, meaning the header number might be a piece of text or it might literally be nothing.
Because not every single header in a book has a number. Some headers are just titles. So naturally, the intuitive leap is to make the number optional. You use maybe.
But wait, let me push back on this a little bit. If I am building a software product or, really any kind of complex system, I don't know what my users will want a year from now. I don't know how this book structure might evolve.
That's true.
If I make the code rigid, won't it just shatter the moment things change?
Yeah.
Isn't flexibility usually the ultimate goal? Like, why is giving a programmer the mere option to include a number suddenly a trap?
That is the exact instinct that leads to the trap. And it is a completely understandable human instinct.
Okay.
We crave flexibility because we fear the unknown, but you have to separate feature flexibility from structural fragility.
Structural fragility.
Right. To understand why maybe became a trap here, look at what Ang was promising the system.
Okay.
The header info bucket was strictly supposed to represent the metadata of a numbered header.
Okay, numbered header.
Right. By making the fields inside it optional, by telling the system that the prefix, the unit, and crucially the number itself might be nothing. You have just made it mathematically possible to construct a numbered header that does not actually possess a number.
Oh, wow. You've built a contradiction right into the foundation.
You've created a paradox in the code.
Right.
A theoretically numbered header where the number equals nothing.
It's like those infuriating drop-down menus you encounter on poorly designed websites.
Oh, I know the ones.
The ones where you are forced to select your job title from a mandatory list, but your actual job isn't on the list.
Yes.
So you just select other or CEO just to get to the next page. Like the system gave you the flexibility to choose, but in doing so, it forced you to generate garbage data that the company now has to deal with.
Exactly. Which brings us to the real-world consequence for you, the listener, whether you are coding or managing a team.
Yeah.
If a state is impossible in reality, like a numbered chapter without a number, but it is possible to represent it in your system, you now have to spend your time writing defensive measures against it. We actually do this in our daily lives all the time. We set up elaborate mental checks to stop ourselves from getting distracted or, eating junk food, rather than just changing our environment so the distraction isn't even there.
That makes total sense.
In software, this is called defensive programming.
Defensive programming.
Yeah.
Building the walls around the mistake.
Right. So Ang had a core function in the program called rebuild header.
Okay.
Because of all those flexible maybe types, the old rebuild header code was riddled with anxiety. It was constantly checking over its shoulder.
Like, is there a prefix here?
Yes. Is there a prefix here? No. Okay. Output an empty space instead. Is there a number? No. Okay, do this complex fallback thing.
Wow.
The code was littered with helper functions entirely dedicated to handling these nothing values that shouldn't have even existed in the first place.
It's exhausting just thinking about it. You're basically guarding against ghosts.
Exactly.
You're spending your budget building a high-tech security system to keep out burglars that literally do not exist in your universe.
It is the absolute definition of a defensive programming nightmare. The cognitive load it puts on you is immense. You can never just trust the data flowing through your system. You have to suspect it at every turn.
Well, so we've seen the generic bucket, we've seen the maybe trap, and we've seen how all this well-intentioned flexibility bred absolute chaos and defensive paranoia.
Chaos is the right word.
But here's where it gets really interesting. Because Ang didn't just tweak the system to handle the chaos better. Ang didn't just, build a better security system for the ghosts.
Right.
Ang redesigned the system so the chaos physically cannot exist.
This is the core principle of making illegal states unrepresentable. Ang stopped defending against the impossible and achieved structural integrity instead.
So Ang took that generic block we talked about earlier, the one that allowed bicycles with jet engines.
Right, the one-size-fits-all.
Yeah, and threw it completely out the window. Instead, they replaced it with specific, strict constructors. 3 distinct specialized categories: block volume, block chapter, and block keyword.
And for those who might not be deep into programming, we should probably define what a constructor is here.
I was literally just going to ask, for those of us who don't write code, what exactly is a constructor? Is it just like a blueprint for making a specific type of object?
A blueprint is a great way to think of it. A constructor is the specific mechanism the code uses to create a piece of data.
Okay.
So instead of one generic blueprint with a bunch of flexible optional tags that you can staple on later, Ang built 3 custom-made, highly specific blueprints.
It makes me think of physical affordances in design.
Oh, like what?
Like a 3-prong plug for an electrical outlet. Or, the new USB-C cables versus the old frustrating USB-A ones where you always try to plug it in upside down.
Right.
Actually, a puzzle piece is an even better analogy.
Okay, I like that.
A puzzle piece only physically fits into the exact spot where it belongs. You don't need to print a warning label on a puzzle piece telling the user not to force it in the wrong spot, because they physically can't do it.
Exactly.
The shape of the piece itself dictates exactly how it can be used.
That analogy perfectly captures what Ang did. They reshaped the code to act like puzzle pieces.
How so?
Look at how they redefined block volume. It no longer accepts an arbitrary integer for the level. It only accepts text for the title and the header info.
Wait, really? No level input at all?
Nope. Because a volume in a book is always level 1. The level isn't something you input anymore. It is structurally implicit in the blueprint itself.
That's brilliant. So you physically cannot tell the system a volume is level 2 because the slot to input a level just no longer exists on that form.
Exactly. And look at how they changed block keyword. The old version used to accept header info, which caused all that confusion about chapter numbers getting attached to keywords.
Right.
The new version, block keyword only accepts text. That's it. It is physically impossible to attach irrelevant numbering data to a keyword now.
So what happened to the maybe trap, like the optional numbers that were causing all the anxiety?
Ang was ruthless. They removed the maybe types from header info completely.
Wow, just deleted them.
Yeah. In the new code, the prefix is mathematically guaranteed to be a character. The number is guaranteed to be text. It is now guaranteed at the type level that every single parsed header info contains a prefix, a number, and a unit.
So if you try to pass it a nothing, like if you try to hand it a chapter with no number,
the code won't even compile. The system rejects it before it even runs.
let's clarify that for the non-coders, because compile time versus runtime is a huge distinction here.
Yeah.
The mechanism of how the system rejects it is super important.
Okay, think of a compiler like an extremely strict book editor.
Yeah.
Compile time is when the editor is reading your manuscript before it ever goes to the printer. If the editor sees a sentence that breaks the fundamental rules of grammar, they reject the book. It doesn't get published.
Right.
Runtime, on the other hand, is when the book is already printed, it's on the shelves, and a reader is reading it. A runtime error is the reader finding a glaring typo while they're sitting in their living room.
Ah, I love that. So compile time is like our vehicle registration form physically repelling the ink from your pen if you try to write jet engine on a bicycle application.
Yes.
It doesn't just fail later when the clerk reads it. It fails the moment you try to create it. That is incredibly satisfying. The system just says, I don't know what this is, but it breaks the fundamental laws of physics we established, so I'm not accepting it.
Exactly. And let's look at the mechanics of how this changed Ang's actual working code, because the simplification is stunning.
Okay, let's see it.
Remember the parsing code for keywords we discussed? It was called PKW.
Right, the function that had to handle the old, weird, generic block.
Under the old system, to satisfy that flexible, generic type signature, the PKW code had to construct dummy data.
Dummy data.
Yeah, it had to build a fake header info filled with nothings and blank text strings just to plug the holes in the generic bucket.
Yeah.
It was literally generating garbage data just to keep the compiler happy.
Oh, man. It's like writing NA, 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 NA on 50 separate lines of a tax form just so the automated system will let you click submit.
Yes, but now, with the new block keyword puzzle piece that just takes a single text value, the PKW function just returns the keyword text. All that dummy data just vanished.
Wow.
It shrank down to almost nothing. And that anxious, paranoid rebuild header function we talked about, the one constantly looking over its shoulder for nothing.
Someone guarding against the ghosts.
Without the maybe types, the ghosts are gone. The new rebuild header relies on direct pattern matching.
Okay, wait, what does pattern matching actually mean in this context? Like, how is that different from what it was doing before?
Good question. In the old code, the system was using what we call wildcard pattern matches. It was essentially saying, I might get a number, I might get a blank space, I might get garbage. Whatever I get, I'll try to catch it and figure it out.
Just casting a wide, sloppy net?
Exactly. Direct pattern matching means the system says, I am looking for a very specific shape, a prefix, a number, and a unit. And because of the new strict blueprints, it knows with 100% mathematical certainty that if it receives a header info, those three things are guaranteed to be there.
That's amazing.
It just grabs the guaranteed values and uses them. No fallback values, no empty spaces, just direct execution.
So, what does this all mean? We've gone pretty deep into the weeds of Haskell constructors, compile time errors, and pattern matching. Let's pull back and look at the overarching benefits. The payoff.
Yep.
The first thing Ang notes in the blog is that the code base just shrank naturally.
It's addition by subtraction. When you remove impossible states, you get to delete all the boilerplate code you wrote to handle them.
Boilerplate being like all that repetitive, tedious code you have to write just to keep the system's plumbing working, like the dummy data in the NA field.
Exactly.
So Ang deleted, maybe checks, wildcard pattern matches, and dummy fallback values. And here's a huge one, fewer unit tests.
Oh, this is a big deal. Unit tests are the little automated exams programmers write to make sure a specific piece of code behaves correctly under pressure.
Right.
Ang needed fewer of them because you no longer have to write tests to ensure your code handles impossible runtime edge cases safely. The compiler, our strict editor, does the testing for you by simply refusing to acknowledge the impossible states in the first place.
That saves so much time. And beyond just shrinking the code, Ang talks about the domain model.
Right.
The domain model, in this case the block AST, the abstract syntax tree, which for the non-programmers is basically just the internal map the computer uses to understand the text of the book.
Right, the mental map.
Ang says this AST now accurately reflects reality.
This is the holy grail of system design. When your virtual model matches physical reality, volumes don't have sublevels in the real world. They don't have them in the code. Keywords don't have numbers in the real world. They don't have them in the code.
Ang summarizes this beautifully by saying, the types are now an accurate and self-enforcing documentation.
That's such a great quote.
Can you unpack that phrase for us? Self-enforcing documentation. Why is a system that explains itself better than a system with a giant comprehensive instruction manual?
Well, if we connect this to the bigger picture, it really comes down to cognitive load and human error.
Okay.
An instruction manual, or in coding terms, a big block of comments explaining how to use a function, relies entirely on human compliance. It is basically a sign that says, please don't put a level 2 on a volume.
It's a sign that says, please keep off the grass.
Yes. It requires the user to read it, internalize it, remember it, and consciously choose to obey it every single time. But human beings are tired, we get distracted, and we are incredibly prone to mistakes.
Oh, totally.
Self-enforcing documentation means the rules aren't written on a sign. They are built into the physical architecture. It's not a sign saying, keep off the grass. It's a solid brick wall built around the grass.
I love that.
Oh.
You aren't fighting your tools anymore. You aren't constantly checking the manual to make sure you're holding the tool right.
Right. The tools guide you to the only logical outcome. When your domain model matches reality perfectly, The cognitive load on the creator drops to almost zero. You don't have to remember the rules because the system literally will not let you break them. You are leveraging the system to its fullest potential.
That is just a massive paradigm shift.
Hmm.
All right, let's wrap this up. We started with Ang's generic, overly flexible code, a system full of maybes and generic buckets that allowed for nonsensical illegal states like numbered keywords without numbers.
The bicycles with jet engines.
Exactly. And we saw how that well-intentioned flexibility forced the creation of paranoid defensive code to guard against data that shouldn't even exist. And then we saw the solution. Stripping away the generic buckets, creating strict, specialized puzzle pieces, and mathematically guaranteeing the data types.
Making the illegal states completely unrepresentable, resulting in a code base that is smaller, infinitely safer, and perfectly mirrors the reality it is trying to map.
It's brilliant. And as promised, it really has nothing to do with knowing Haskell and everything to do with how we design the worlds we operate in.
So true. And I want to leave you with a final thought to mull over. If we step entirely away from programming for a second and look at our own daily lives,
Okay.
what impossible states are we constantly defending against? We seeded this idea earlier when we talked about the paranoia of that rebuild header function.
Oh, that's a great question to apply to ourselves.
Think about your daily habits. When you are sitting at your desk trying to focus on deep work, do you rely on sheer willpower to ignore the distractions on your phone?
All the time.
Because that is defensive programming. You are allowing the distraction to exist in your environment, and you are spending precious mental energy constantly checking it and fighting it.
You're running the maybe trap on your own attention span. You're constantly running a background check like, did it buzz? No. Okay, back to work.
Exactly. So what is the alternative? How do you make the illegal state unrepresentable in your own life?
Right.
You put the phone in another room. You design your physical system so that reaching for the phone without getting up and breaking your workflow is physically impossible. The distraction cannot be represented in your immediate environment.
You change the architecture of the room so you don't need to rely on willpower.
This raises an important question for all of us, really. How can we redesign our own daily systems, our workflows, our homes, so we don't have to constantly defend against our own mistakes?
It goes right back to the beginning. Instead of spending all your time anticipating every single way things could go wrong, just design the system so the mistake is impossible to make in the first place. You don't need a warning label if you build a better puzzle piece.